Hi guys, welcome back. We're going to talk about rate of change today. So, rate of change is the ratio that compares the amount of change in the dependent variable to the amount of change in the independent variable. So what that means is the rate of change is really the change in the dependent variable over the change in the independent variable. And to make that a little bit easier, this is the change in y, so in the y variable, over the change in the x variable, okay? So this is really the one that's probably the easiest to understand and to help us, okay? So let's look at an example problem. So we have the table shows the cost of mailing a 1 ounce letter in different years. We're going to find the rate of change in cost for each interval. During which interval did the cost increase at the greatest rate, okay? So we're going to find the rate for each one of these. So from 1988 to 1990, okay? So I'm going to look at my y values and then my x values. So the change in y is going to be 25 minus 25 because the y's were exactly the same. And then we're going to do 1990 minus 1988 because those are the x values here. Well, 25 minus 25 is 0, and 1990 minus 1998 is 2. Well, 0 divided by 2 is 0. So there was a 0-cent change per year between 88 and 99 because the cost stayed the same. Okay. So for the next one, we're going from 90 to 91. So I'm looking at my change in x, change in y. So I'm going to have 29. I always put my bigger one first just to make my multiplying or subtracting easier. So since 29 goes with 91, I'm going to have 1991 first here, minus 1990. Okay, 29 minus 25 is 4, and 91 minus 90 is 1. So this would be a 4-cent change per year. Okay. So go ahead, why don't you try 91 to 2004 and see what you get. So we would have 37 minus 29 if we look at our chart over 2004 minus 1991. Okay, because again, we're just looking at the y's and x's here. Okay, so 37 minus 29 is 8, and 2004 minus 1991 would be 13. And if we divide those, we'd get approximately 0.62 cents per year. So it's less than a 1-cent change. Okay, so that's pretty small. Okay, and then we're going to go ahead and do our 2004 to 2008. So we're going to have 42 minus 37, okay, over 2008 minus 2004. Okay, and then we are going to go ahead and do our subtraction, which would be 5 over 4, which if we divide that would be 1.25 cents per year. Okay. Now, the question asked us to find all of the rates of change between each interval, which we did, and then it says which year was the greatest increase. So we're looking at the numbers. What number is biggest here? So the biggest increase here was between 90 and 91, okay, because we had a 4-cent increase per year, whereas in all the other ones we had either less than a cent or only 1 cent or no change, right? So that would be the greatest change for that year. Okay. All right. So a shortcut is to think of slope, okay? And we have these words here, and the rise means the difference in the y values, which the change in y we talked about earlier. So it's rise over run. So the difference in the x values is the run, which is why the run is on the bottom. So we have rise over run. Okay, so remember that. Okay, so now we can find the slope using a graph. Okay, so if I wasn't given a table, I was given a graph. So remember, we have that wonderful rise over run. So rise is either the up and down, and the run is the left to right. Okay, so I'm looking from these 2 points. So I can see on my graph I have 2 points plotted here. So I start at the lower one because that just makes life a little bit easier, but you could start at the upper one. So I'm just going to say I'm going to go up 1, 2, 3. So my rise was 3, and my run is 1, 2. Okay. Now I can do those jumps because I'm counting by ones. If I was counting by twos, make sure you're looking at that would be 2, 4, 6, right, instead. So the slope of this is 3 over 2. So let's just do that one more time, make sure we're all good here. So I said, okay, how many times do I have to go up in order to get to my new point? So I had to go up 1, 2, 3. And I would have to go over 2 to get to my point. So that's why it's 3 over 2. All right, let's do one more because I have some students who always struggle with this. So I'm just going to draw a line on this one. So let's say this was here and here. Okay. So here I'm going up 2, right? So my rise would be 2. But then I'm going to the left 2. So that would be negative 2. So if I go to the left or if I go down to get to my point, it's negative, okay? So 2 divided by negative 2 is a negative 1. So my slope here would be negative 1, okay? So just be careful of that. If I have to go to the left or go down, I have to make that number negative. And actually, you could have done that here as well. If we looked at this problem, you could have started at this point and gone down 1, 2, 3. So the rise would have been negative 3. And we would have gone over negative 2. And a negative over a negative gets a positive. So we get the same answer whether we go up and over or down and to the left. Okay? All right, special cases. There are 2 special cases, and sometimes I have a lot of students mess these up. So we have the horizontal slope. Okay, so if we think about this, the rise over the run. Okay, if we pick 2 points on this plot, let's say here and here, I don't have to go up or down any to get to my next point, right? So my rise is 0, and then my run is 1, 2. Well, 0 over 2 is 0. So anytime we see a horizontal line, the slope will be 0. And how I think of this is skiing, right? If you're cross-country skiing, there's no slope, right? You have to power your skis to go, right? So it's a slope of 0. Okay. Now a vertical slope, again, if we look at the rise over run here, okay, if I pick 2 points on the line, it doesn't matter what 2 points, I'm going up 1, 2, 3. But then I don't have to go left or right to get to my next point, so that's 0. We cannot divide anything by 0. We talked about this earlier in the school year. This is undefined, okay? We cannot divide by 0. So if we have a slope like this, anytime you see a perfectly horizontal or perfectly vertical line, that's a slope of 0, or slope of undefined, apologize. So this is like if you were gonna go skiing down this, that would be very, very bad, right? You would die, okay? So it's undefined. We cannot go skiing down this slope. Whereas this would be cross-country skiing, that's a 0. So the 2 special cases are 0 and undefined. Okay. You can also have a general sense of a line. We kind of talked about this with correlation earlier this chapter. So a positive slope will look like this. It'll go in the upward direction. And a negative slope would go in the downward direction. Okay, just like when we talked about our correlations. Okay, so those are our 4 special cases. Horizontal will always be 0. Vertical will always be undefined. Positive will go in the upward direction. Negative will go in the downward. Bye.